I really don't want to be in this math class right now. I want to go bed.
Your lunch is ready.
Good afternoon, everybody. Hello.
Afternoon.
So you see, this is why I don't like the online classes, because you see, not a lot of persons turn up. So 15 persons. I don't like the online thing. I tell it, I don't like it. All right, but circumstances would have been a choice. All right, so as I said in the group, I would take this opportunity to do more than I originally planned to do in terms of examples. So I'm just going to work some vectors examples from past papers. All right, the more recent past papers, as you can see on the screen here, what I have is the 2023, May 2023 paper. We're looking at the vectors question. All right, I'm going to do the same thing tomorrow, just practicing from past papers. And then we'll come back to class Sunday, Monday. Then we'll go back to the original plan. All right, I'm also going to practice on Saturday. So I'm going to get a good bit of practice, all right, based on what is happening. And as always, you know what it is. You need to go and redo all the questions that I'm doing. All right, you need to redo all the questions that I am doing. Very important. All right. So this is the 2023 paper, the vectors questions, always in section 2. All right, always in section 2, and it's the last question. Either it's part A or part B of the last question. See, vectors and matrices. All right, and the vectors that on this paper to be the very last question on the paper. All right, so look at it. It gives us these three vectors: WX, XY, and ZY. And it says we have to determine each of the following. All right. It says a vector other than 5 minus 1 that is parallel to WX. This is WX. And you want a vector that is parallel to it. Determine a vector. A vector means any vector. Any vector you like that is parallel to this. Remember, any vector that is parallel to it will be a multiple of it. Simple as that, you know. It doesn't have to be one of these. Let me just say a vector other than this that is parallel to WX. And WX is the 5, negative 1. Let's write it. The WX is the 5, negative 1. So any vector that's a multiple of that is okay. So I can call that vector V, and I'm going to put 2 times 5, -1. It's multiplied by 2. You could use any multiple you like. Any multiple, even a fraction. You could put half, 3/4. Any multiple of the vector will be parallel to it. Two vectors are parallel when one is a multiple of the next. I like this question. So I'm just using 2. So a vector that is parallel to this would be 10, -2. Because it is a multiple of the 5, -1. That is it. I could have used 3, I could have used 4, I could have used a half, I could have used any value here that I want. In fact,
my bro is okay.
Hey, who is this? I bet you exactly. Mute your mic, please. All right. So, in fact, one neat way to do a question like this would be to maybe give them something like this and say, all right, let's do it another way. Would say something like a vector that is equal to k times 5, -1 would work out to be 5k minus k. I'm going to define k for them now. K is a member of any real number that is not, and k is not equal to 1, because they said they don't want the vector to be 5, 1. So you're saying you could use any real number for k, any real number, positive, negative, fraction, any real number for k could be used. You just don't want it to be 1, because I said they don't want the vector to be the same. That's what they said here. They said other than this one. So you don't want k to be 1. That's what I would state this. So it's a neat way to give an answer for that. But if you give this, fine, that's okay. But if you give them something like this, trust me, they'll have to give you a mark still. But this is good enough. All right? But understand that. I just want to make sure but understand what is happening. But understand that this would be a vector parallel to 5, -2. And you could put 15, -3 if you want it to multiply by 3. If you multiply by 4, it will be 20, -4. Any vector that is a multiple of this will be parallel to it. But understand that? Everybody good at that? Before we move on?
Yes, sir.
Yes, sir.
All right, good. Now this vector now, they're asking us to calculate the vector WY. So look at what we have. WY. What it is that you want to go from W to Y. So to go from W to Y, based on these two vectors, looks like I can go from W to X first and then go from X to Y. Simple. Remember, vectors at this level is just basically how you go from point to point. So I'm going to set up a vector equation. I say, okay, if I want to go to Y, to going from W to Y is the same as, remember, equals means is the same as, right? When you're doing vectors, the equal means is the same as going from W to X. By back with me? Another reason why I don't like online. I have a challenge of technology. Okay. Right. So I was saying 5 and the minus 3, same as 5 minus 3 is 2. Negative 1 and 7. Negative 1 plus 7, same as 7 minus 1 is 6. That's my answer. That's WY. That is WY. Then down here, they want us to do XZ. Want us to go from X to Z. So let's look at it. So let's see which two vectors we can use. So this has X in it. This also has X in it too, you know, but we want to go from X to Z. So like we want to start at X. So a good vector to start with is this one. And this one has Z in it. So it's like we want to go from X to Z. If you notice, this has a Y on it, and this has a Y on it. Just that ideally, you would want to go from X to Y and then go from Y to Z. But this has ZY. But no problem. If this is ZY, and we really want YZ, what we have to remember is that the YZ that we want is really equal to minus ZY. I'll put another way. If I switch around these letters, then I'm switching the direction. So I have to change the sign of these values. Remember, when you change direction in vectors, that is indicated with a negative sign. All right? So can look at it that way. But if I even apply the minus YZ, which is this is YZ, then I'll be minusing this and minusing that. So this will come out to be minus 8, 7. So this is YZ. And so now I can go from X to Z by stopping at Y first. So I can go X to Y and then go from Y to Z. That's what I'm going to do. And because they gave me ZY, I had to work out what YZ is by switching around the ZY, flipping around the ZY here and change the sign of these values. All right, so the YZ is this. So I'm going to set it up that way. All right, so this would be the XZ. XZ would be equal to this, which means to go from X to Z is the same as going from X to Y first and then going from Y to Z. So I'm going to be using this XY, which is this, and this YZ, which is that. All right, that's what we're going to be using. So let's do it down here. I can literally just copy this down. The same equation. I need to write right here. Put it here. And take off this one. That's it. All right. So the XZ, the XY, sorry, up here is minus 3,4. Minus 3,7, sorry, minus 3,7. And the YZ is a negative ZY, so it becomes negative 8,7. Negative 8,7. I like this question. And so the answer of XZ is therefore negative 3 and a negative 8 is negative 11. And 7 and 7 is 14. 14. That is the answer. What are we going to do that?
Yes, sir.
Yes, sir.
All right. So questions like these, remember, you're going to work them over again. Questions like these are going to go and work them over again. So this question, we had to use the inverse of the ZY, right? But we wanted the YZ. So we have to use the inverse. Remember, the inverse is obtained by you change the direction and introduce a negative sign. Opposite direction in vectors is indicated with a negative sign. Here now they want the modulus of XY. The modulus, remember the modulus is the length. This is the modulus, length or magnitude of XY. So remember, if you have a vector V and the vector is AB like that, then the modulus of that vector V is simply equal to the square root of A squared plus B squared. Why is that? Because if the vector is V like this, then the AB here really means A this way and B that way. So this is A and this is B. And so if you want to find this length or this length, we are using Pythagoras' theorem, which is what this is. The modulus is the length of the vector, the length of this side, right? And that's where that comes about. That's what that comes about. So I need to look at the values on the XY matrix. And the XY matrix is this one, right? -3, 7, -3, 7. All right. So the XY -3, 7. Let's write it here. The XY matrix, the XY vector, I should say, is -3, 7. And so if we're going to get the modulus of this, it's going to be equal to the square root of the -3 squared plus the 7 squared. Now, normally, I don't have to put the negative on this when I'm putting it here. I can just use the 3 because the -3 squared and +3 squared is the same, right? And the negative is really indicating only of direction. So this vector xy, if we were to sketch out this vector xy, it means to go from x to y. If x is right here, I want to reach y. It means I have to go 3 units back and 7 units up. So this will be 3 units, and this will be 7 units. 7 units. That's what this vector here means, to reach where y is located. That's where y would be. And the vector would be this one. I'm going to draw in purple. This would be the vector. That's what the vector would look. That would be the vector xy. And so if you want to find the length of this line, you see, based on Pythagoras' theorem, it becomes the square root of 3 squared plus 4 squared. And that is why I'm saying you don't have to put the negative here. You can just put the square root of 3 squared plus 4 plus 7 squared. All right, because the negative in here is just indicating that you're going to the left. That's all. All right, but in any case, if you work with the negative, the answer is going to be the same. It becomes the square root. This becomes 9. And 7 7 is 49. And that becomes 9 is 80, becomes square root of 58. And I can actually leave this as my answer, units. I can leave that as my answer right there. All right, so I'm just leaving these on the screen just to remind us of, where some of these things come from, like the formula. But okay with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right.
Yes,
Good.
sir.
All right. Good. We can take this off. Okay. That finishes that question. That was a 2023 June exam paper. All right. Let's look at 2022. Let's look at 2022. 2022, right here. And we are looking for the vectors question, which is at the back. All right, there it is. Okay, so it's part C. Let's see what is on part. So part, this is the matrices. All right, so here we are. Here we are. All right, let's go. This question says, in the diagram below, I like diagram vectors question because you can see your way around. You can check your answers. So what you get by calculation, you can check and see if it makes sense on the diagram. So I like diagram vectors questions. All right, it says in the diagram below, O is the origin. It says OX is U. So they tell us that this vector right here is U. OY is V. So this vector right here is V. All right. It says OX and OY are extended. Another word for extend, I can tell you from now that you might see in some questions is the word produced. So if you read in a question and it says a line is produced, it means extended. That's a fancy word that they use sometimes for extended. So you might say OX is produced. So in the case, what they would say is that OX is produced to A. Means OX is extended out to A. All right, so look out for that word sometimes. Instead of extended, it might say produced. So that X and Y are the midpoints of OA and OB. All right, so what they're basically saying now is that this becomes the midpoint of this whole vector here. And this becomes the midpoint of this whole vector here. Now, common sense now. If the vector from here to here is U, and it's the same straight line, somebody tell me, what is the vector from X to A?
They would have been the same thing.
Same U. Because the same direction as this, and the same size, same length, because that's midpoint. So the same U. So it means that OA is 2U. The whole thing now is 2U. And there's a similar situation on this side, where because this length and this length is the same, and is the same one direction out here, it means that the vector from here to here is also equal to this one, which is V. So I can put it on the diagram right here. Is V. Is V. Now I want you to notice, they give it these U and the V as italic letters. Look at it carefully. It's not your normal U and your normal V that they give it. They put it in italic letters because they want to show it as a vector component. All right, they want you to see it as a vector component. If you compare this V and this V, it's that this one is written differently because it is indicated as a vector. What I do, instead of writing it pretty like that, I underline it. So I underline the U and I underline the V instead of trying to write them as italic letters. And I would suggest that you do that as well, because you have to be able to separate vector components from scalar components. Because it could be that the question give you a scalar, like for example, KV. If they give you a scalar K, I don't know what K is. K is some value like 2 or 3 or a third or a half or 3/4. That's what this is, some scalar value. But this is the vector component. You have to be able to differentiate them. So this would not be a vector because I don't underline it. It's just a scalar quantity. And then this will be a vector quantity. All right, so you have to be able to differentiate the vector quantities from the scalar quantities. Remember, mathematics is a subject of symbols. So you have to use the right symbols for the right things. So instead of trying to write these small vectors in italic letters, I underline mine. I underline them. I know when they write the vectors with capital letters, you must put the arrow on top. You must put the arrows on top because it is different. So this is different from OX. OX is just meaning the line OX or the length of the line OX. But with the arrow on top, it means how do I go from O to X? What vector takes me from O to X? That's what this means. Not just talking about the length alone. All right, you have to be able to differentiate scalar quantities from vector quantities. All right, so this is what we know based on information. All right, and we now know also that OB all the way out here is 2V. OB is 2V, so we know all of that. All right, let's continue. Question says, express BX in terms of U and V, meaning U and V must be in the answer. So I always say, if you know the position vector of the B, I know the position vector of the X, then you can use O times the last minus O times the first. If you don't know them, then you have to go on the diagram. In this case, we know them. What do we know? We know the OB. The OB is all of this, 2V, right? Oh, wow. Press the wrong thing. Jesus. Sorry, guys. I think just drop down and press it. Right. So OB is 2V. So I'm going to write it here. Once you know the portion vectors, you use them. 2V. And what is OX? OX is U right here. OX is U. So I can find BX using O times the last minus O times the first. I don't have to use the diagram to find it. So BX, I'm going to use the formula, the vector formula for displacement, which is O times the last, X is the last, minus O times the first, B is the first. This is a classic formula for finding a displacement vector using the position vectors. It's a position vector of the last minus a position vector of the first. Last minus first. So basically then it becomes OX, which is this one, minus OB, which is this one, 2V. That is the answer. BX is equal to that. And you can check if it makes sense on the diagram. Right? You can check if it makes sense to go from B to X. Right? This is saying go IU and then go minus 2V. Let's look at it. Go IU. So starting here, I could go IU, because once I go this direction, same as this. Then this is a U over here. This is also U. Same length and same direction as that. Right? And then now it's saying go minus 2V. Now remember, 2V is all of this now. But then I'm going to go minus 2V from here. So if I go minus 2V, notice it's taking me to the X. That's minus 2V. So it means that this answer is true. That's what I like about the diagrams. You can check the answer, see if it makes sense. Could have also looked at the diagram and said, okay, how do I go from B to X? I could go minus, starting here, I go minus 2V down to O. That's the minus 2V here still, the minus 2V. And then I go U. That's the U right there, minus 2V plus U. So you know the answer is correct. The diagram confirms it. And that's what I like about vectors questions. You can confirm your answer. All right, let's continue. All right. Next question wants us to calculate the vector. It says, that's what it says. It says, given that YA and BX intersect at M and BM is 2 times MX. All right. Let's put all of this information on the diagram. When you're doing vectors, you want to put everything that they're talking about on the diagram. Indicate everything on the diagram. All right, let's look at it. They want us to express BM in terms of U and B, but let's put on the diagram first. All right. So YA and BX, they intersect at M. So I need to draw the line YA and the line BX on the diagram. Let's go on the diagram. YA and BX. Let's draw them in. YA and BX. So YA is this one up here. From here to here is YA. So use a ruler, draw a straight line. That is YA. Then BX is from here to here. Again, use a ruler and draw a straight line down there. They intersect at M. So this point here is M. Right? And then they tell you something about the relationship of M on this line. Let's look what they said. Let's look what they said. They said BM is 2 times MX. BM is 2 times MX. So BM has 2 MX in it. So I'm going to write this relationship on the line, that I said, So we'll come up with a ratio of the line. So BM, the line BM, it has 2 MX in it. So look how I'm going to write it now. BM and MX. All right, so this is BM. Look at it now, guys. Pay attention now. Learn these little skills. This is BM. It has 2 MX in it. Look what I'm going to do now. So this is BM, and they tell us it is 2 MX. So I wrote what they said on it. And this is MX itself. So I'm going to write 1 MX on this one. So look what I'm doing now. I'm sure now that the line has 3 parts. This is 2/3 of it, and this is 1/3 of it. If I erase the MX now, look carefully. I'm going to erase the MX. Erase the MX. It means that this whole line is in the ratio 2 to 1. This is 2 parts of the entire line, and this is 1 part of the entire line. That's what it means. So it means, therefore, that this is 2/3 of BX. 2/3 of BX. And it also means that this is 1/3 of BX. This length is 1/3 of BX. But can appreciate that before we move on. But understand that?
Yes, sir.
I want to watch over the video and see how I do it, and do it again by yourself, Or break down the ratio of the line. And 6 like to give questions with 2/3 and 1/3 part. Always they like to do that. All right? Always they like to do that. Remember now, we know this vector already now, bx now. We already know bx. We know the vector from b to x, all the way up here. So I can tell you from now that this bm based on this diagram is 2/3 of the bx that we know. I can tell you that from now, because that is 2 of the 3 parts of the line bx. And similarly, this one, mx, I am going the same direction as the direction of bx. The mx from here to here is 1/3. The mx, this is this part, from here to here, is 1/3 of the whole thing. It is mx is 1/3 of the entire bx. Just by that information, I'm sure you're gonna have to use this information or this information. Must use that information. When you practice vectors questions, these are the things that you'll know that you have to find out these things and use them. All right, well, let's look at the question now. So we have deduced these from the information that they gave us. Can literally just copy these now down and write and copy them down so we can use them. This, copy this down. Okay, we're gonna need it down here. I can tell you, we're gonna need it down here. We're gonna need it. Oh, that's what I get. Delete. So still have the old copy in this thing. I have to copy this. Let's put it here. And see there, they're asking us for one of them. They're asking us for the BM, which is this. All right, they're asking us for the BM. But I want the answer in terms of the U and the V. So the BM, as we said, based on the ratio of the line, is 2/3 of the entire line, BX. Remember what the BX was? The BX was U minus 2V. Mute your mic, please.
OM plus BM.
Mute your mic, please.
No.
Mute your mic, please. Keep your mics muted. Right? So remember that the BX is U minus 2V. So we're just going to replace this with U minus 2V. So this becomes 2/3 of U minus 2V. The answer must be given in terms of U and V. So it's 2/3 of this, which becomes 2/3 U, and 2/3 of this becomes 4, because the 2 times 2 is 4, which is minus 4 over 3V. So this is BM. Think you understand that, guys? But understand that?
Yes,
Yes,
sir.
sir.
When you watch over the video and do it by yourself. Let's continue. This question says, using a vectors method, now show that ym to ya is 1 to 3. Show that ym to ya is 1 to 3. All right? Ya to ym is 1 to 3. And it says using a vectors method. So if we're going to use a vectors method, we need to find the vector ym and the vector ya. You have to get the vector component out of it and show that it is 1 to 3. ym. Let's look at the diagram now. We're going to need ym and we're going to need ya. Let's look at the diagram now. We need ym and ya. So let's look at what we need. We need ym and we need ya. That's what we need. Ym and ya. Now ya kind of easy from here to here, because you can see that we know the position vector of the y and the position vector of the a. Or we can say is minus v plus 2u. That's ya. But how do we get the ym right here? How do we get this vector? Somebody tell me. How do I get ym? Anybody can tell me how you think we can get the vector ym? That's this vector right here. Ym. Go ahead, tell me. Remember, I have to use the vector direction that you know. Tell me. Yeah.
Oh, I was just going to say like put it as a ratio, but
Not yet.
No, man, you need to calculate this. You need to work out what the vector ym is. Look at the diagram and tell me how you could go from y to m. You're trying to find the vector ym. Look at the diagram and tell me how you could go from y to m, going along vector direction that you already know.
You can go
Yeah.
y.
Continue.
You can go YB and then BM.
Exactly. And it makes sense to go that route because they just asked us for BM. So you want to use it. They just asked you for BM, you know. See it here? So you want to use it. That's what vectors questions are. As they ask you a question up here, you're using it down here. And you're using it down here. And that's how the questions usually set up. They ask you for something now, the next question, you're looking to use it. Right? Just as though up here they ask us for the BM, the BX, and then we use it down here to find the BM. See there? And now that we find the BM, they're asking us now to find YM and YA. Because in order to use a vectors method to get differentiation, we have to find the vector YM. And we have to find the vector YA. But the YA is straightforward. This is the one that you have to work out now. And to work out this one, this plays a part of it. Because the YA is straightforward. Because we know the Poisson vector of Y and we know the Poisson vector of A. Right? So this is the one that might, you have to work out. And again, you want to look to use this. So you are correct. Look at the diagram. If you want to go from Y to M, what he's saying, come to A first, or come to B first, I mean. So you're going to use Y to B, and then use BM, B to M. That's all you have to do. We can work it out right here on the screen and then copy it down. Let's do it. So it's in front of us. We want to work out YM. Let's work it out right here, where we can see it on the screen, and then copy it down and move it down. So YM, going from Y to M, is the same as going from Y to B, and then going from B to M. B to M, not Y, B to M. The YB is V. See, I have it on the diagram, so that is just V. So this is just V plus, and the BM, I have it down here. We just worked it out a while ago. This is the BM. Let me just copy it up now. Just copy it up. That is the BM. Let's paste it right here. Right? And you always consolidate your values. This is the YM. YM. And consolidate the values of the V. Right? So this is 2/3 U, not changing. And then V minus 4/3. Now all you have to do to work out this and this quickly is to put this one as if it is 3/3. They're really doing 3 minus 4. 3 minus 4 is -1. So like -1/3, -1/3 V. So it becomes -1/3 V. That is YM. Right? And then YA, remember, based on the diagram, YA easy in because OA minus OY. Or you can look at it, go from Y to A, it is minus V. Come back here, minus V, and then go up 2U. Minus V plus 2U, which is same as 2U minus V. Same as 2U minus V. Or we could look at it and say, YA is OA minus OY. The OA is 2U up here, so. Minus the OY is just V. Same result. But I want to get these values in the same order as they are here. I want the U value first and then the V value next. Keep it consistent. So now I'm really comparing these two vectors to show that one of them is 1/3 of the next one. They have a ratio of 1 to 3. Right? This is YA. So I'm now comparing this vector and this vector. I can see it's 3 times already. Let's copy them down onto the next page. Let's copy all of this down to the next page. Because we just put it in where the diagram is so we can see. Let's copy it down. I should cut it down. So I'm going to paste it here. Put it on this side. All right, so let me show you. Let me put it in purple now and go back to what we said in class. All right, you want to establish this. We have to appreciate you, you see that this is the same as saying ym over ya is 1 over 3, you know. That's what it is, you know. And where this come from? If I cross multiply the 3 up here, and multiply this up here, then this really comes from, came from 3ym equals ya. If we're working in reverse. And then now what did that mean? That the vectors were on these. So it came from this, you know. So you're supposed to get this from these two. This and this. Supposed to combine and give you that up there, so that you can get to that ratio. All right, if you're working in reverse, when you practice, you know these things. Right? So you know what you're doing, you know what you're gonna get, and you know how to get what you want. You're working in reverse. So this is what you want to end up with. But the method that I showed you to use, right? Let me put it in this box right here. Okay, we're trying to get this ratio. We're trying to get this ratio. To get this ratio, we need to get here. So first, to get to this, we have to get this relationship first. So basically, compare these two vectors now. They are parallel, and in fact, the points are collinear because the common point is y. So the points are collinear. You can see it on the diagram as well. It's one straight line. See, this is one straight line. The 3 points are collinear. All right. So let's continue down here. So I'm comparing this vector and this vector. So I have ym, which is 2/3 u minus 1/3 v. And I have ya, which is just 2u minus v. You must see it already, that easy. Remember, the first step, we want to put these in a relationship and see the relationship between them. Is to get rid of any fractions. That's always the first thing you want to do. Clearly going to multiply by the 3. Lowest common multiple of the 3 is 3 and 3, so multiply by 3. So multiply 2 by 3, it will get rid of the fractions for us. So when I multiply 2 by 3, this becomes 3ym. This becomes 2u. This is a u, you know. It's a u. And this becomes minus v. Multiply by 3 minus v. So if you notice, this and this are already equal. So now we can equate this to this. And so 3ym equals ya. You can equate them. Right? So we're going to say equate, because they are already equal. And when you equate, you're going to get 3ym equals ya. And it really leads now down to this, you know. But you need to go through the correct processes, right? Which is to get the vector component out of it by taking the modulus. So you take the modulus of this side and the modulus of that side. We show it on the next line. So you take the modulus of the left side, which is modulus of 3ym, will be equal to the modulus of ya. So now you're only talking about the length of the line. So when you write the modulus, you can drop off the arrow, because you're taking the direction out of it. It's talking about the length of the lines now. So this side becomes 3ym equals ya. Then you can set up this ratio by dividing by the ya and dividing by the 3. Right? So you're going to get ym over ya equals 1 over 3. And this now means this ratio that they told us. So we can say, therefore, ym to ya equals 1 to 3. This and that, 1 to 3. That's what the question is. You're required to do in this question. Now, a question like this, guys, I would suggest that you go and you work it over again by yourself. Watch over the video and redo the question. watch over the video and do it again. All right, so maybe it's a blessing in disguise that we're doing this class online and it is being recorded. But to that, but okay?
Yes, sir.
Yes, sir.
All right, let's go on and do 2021, June 2021. So remember, everybody should come back to class tomorrow. Everybody, whether in the Sunday class or the Monday class. Everybody come to these classes, these 2 days that we're having online. Because I'll be doing different stuff tomorrow. All right? Doing different stuff tomorrow. 2021. Let's look at the 2021 paper. You can really only fully understand these things by practicing questions, guys. So we have to practice. Right? And I'm explaining them to you, right? And you now go and redo the questions. Watch over the video, redo the questions. They are all related and connected back to what we did in class. It's now applying what we learned. So we did the basics in class, we're now applying them to questions. All right, so this is another vectors question. This is June 2021. This is question 10, part C. It's a vectors question right here. I'll give us a diagram. Again, I like the diagram once. If I can see exactly your way around. You can see your way around. That's what I like about it. All right, so let's go. This question says, the diagram below shows triangle OAB. So this is triangle OAB, that whole triangle there. And it says the vector OA is R. So notice now, guys, you might want to think it is OC that is R, but no, it is actually OA. So this R really is for the entire line. So careful. I don't like that about this question, but a lot of persons looking at the diagram might believe that this OC is R, but it's actually OA based on this information. And OB is S, so this one is okay. All of OB is S. All right, let's see what they says. What they said next. In addition, E is the midpoint of CD. So right here is the midpoint of CD. All right, and you can see that. E is the midpoint of CD. Let's look now. It says OC is 3/4 of OA. OC is 3/4 of OA. This is 3/4 of the entire line. So I'm going to change this vector thing that I put on the diagram now to make the diagram more realistic. So I'm going to erase this, and I'll do this in the exam room as well. Mark it out, because I don't want to be confused. Now, if the whole thing is R, and this is 3/4 of the whole thing, then the vector from O to C, which I'm going to put right here for myself now, which is the vector from O to C I'm talking about, is 3/4 of R. But I get that?
Yes, sir.
And then what is this little piece from here to here? Somebody tell me, from C to A is what then? What to C to A?
1/4.
Beautiful. 1/4. The more information you have, the more you break down all the parts of your diagram, it's better for you. So I'm going to put it there, 1/4 R. All right?
Sure.
Let's see what them, yes?
Can you also say that OC is like 3 AC too?
If
Or
OC, if C, yeah, but it don't make no sense to do that, because the questions is naturally going to ask you to give you answers in terms of S and R. So that's what you want. You want things in terms of S and the R. So if you read the question, it's going to say right in terms of S and R. Those are the vector components. Right? So you are correct. This side is 3 times this side, but you don't need that. That help us now. You want it in terms of the S and the R. That's what you want. So your answers is a vectors question you're doing it now. And they are going to want answers in terms of S and R. So the more you can express things in terms of S and R, the better. You understand that?
all right, sir.
All right, good. And then here now they are saying AD is 2/3 of AB. AD, look now, this side is 2/3 of the whole thing down here. So All right. No, we don't have any vector to use yet, but they're telling us this ratio. 2/3. So I can put a ratio on the line based on that information. This has 2 parts in it, and this has 1 part in it. So I'm going to put a little reminder for myself. Put a little 2 here and a little 1 here. So like the line have 3 total parts, but this is 2 out of the 3. Because the AD, see, the AD is 2/3 of the whole line. So like the whole line is 3 parts, but the AD is just 2 parts. Right? So if this is 2/3 of the whole line, then down here is 1/3 of the whole line. If you want, instead of 2, you could put 2/3 and then put 1/3. So if you want, remind yourself you can put 2/3 here and 1/3 here. But I don't like to do that. I like to just put the parts. So I know 2 parts, 1 part of the entire line I'm talking. So when I'm ready for the vectors, I remember this: 2/3, 1/3. All right. Now look at the question I want us to first find. They want us to find the vector CD. CD. So if you look at the diagram now, guys, and see how you go from C to D. Because we do have the position vector of D. We don't have it. We have the position vector of C, because OC is 3/4 of R. But we don't have the position vector of D. So we're not able to use OD minus OC just yet. We can use OD minus OC because we don't know OD. When you cannot do it this way, you look at the diagram and see how you can go around the diagram from C to D, going along vector direction that you know, or vector direction that you can find. Now, there's an important vector that they did not ask us to find. Normally, they would ask for it first, but they didn't, which is the vector AB from A to B. Well, you can find AB because you know the portion vector of A and you know the portion vector of B. So you actually can find, it's almost like they give you AB indirectly. So from these two, you already know the vector AB. AB is OB minus OA. Now, a lot of questions would have maybe asked you for it, but this one didn't. But no problem, you have to practice. That's why you have to practice, right? To know what is missing, know what you need. When you practice, that's why you have to do a wide variety of questions, right? So the OB is S and the OA is R. So we know that the AB is this. I remember now that the AB is that, but then this is just 2/3 of this. And this is 1/3 of that. But understand that? But understand that, guys?
Sorry.
Are you good with that?
Yes, sir.
Huh?
Yes, sir.
All right. Somebody else was saying something different?
Still like the last part.
Which part? Right here, sir?
Yes, sir. Yes, sir. That part.
Yes, based on the diagram. You can look at the diagram. Now, once they give you this position vector of A and B, they are indirectly giving you the vector AB. Because AB is simply equal to OB minus OA. Where AB is one of the lines that they are referencing here. See, they make reference to it right there. So the vectors question you're doing, so you would need that vector AB. So they didn't ask you to find the vector AB, but you need it. But you can find it because they give you the information to find it. They give the position vector of A and the position vector of B. So if you want to find it, you do that same position vector formula or displacement vector formula. O times the last minus O times the first. What this is, the vector AB right here is OB minus OA. So it becomes this one minus this one. That's what I have here, S minus R. That's the vector OA. That's the vector AB. This is from here to here. This whole line going down this way. That vector. And then now, as I'm saying, based on this information here, this is 2/3 of that. 2/3. And if we want, this is 1/3 of that. 1 out of 3 parts. This is a whole, this represents the whole line AB. Understand that now?
Yes, sir.
All right. But let's continue. So down here, they want us to calculate CD. So tell me now, look at the diagram and tell me how to go from C to D now. C to D. We now know this whole vector down here. So we know the whole thing. I want to say right here, so it's 2/3. Tell me now, how we go from C to D? Going
Sir,
along the vector.
we'll go from CA and into AD.
All right, so go from C to A, and then plus means and then go from A to D. Beautiful. So the CA is okay. We know that it is a quarter R, don't it?
Yes, sir.
But what is the AD? The AD equal
2/3 of AB.
beautiful. It equal 2/3 of AB, 2/3 of this. So we have to write it. So the C, we're gonna put the CA back. We know that, and the AD now is 2/3. Can they tell us right here now? 2/3 of AB. So this is 2/3 of the AB. Where we know the AB now is this. So we can now put in the values now. So the CA is a quarter R, so it becomes a quarter R plus 2/3 of AB means 2/3 of each of that part there. So it's 2/3 S minus 2/3 R. So it becomes 2/3 S. Let's write this better. 2/3 S minus 2/3 R. Okay, if you multiply this by 2/3, we have a 2/3 apart there and 2/3 apart there. So this becomes 2/3 AB. That's what that is, 2/3 AB. Then as always, you consolidate your values. So this is the only S term in it. I'm going to write that back first, 2/3 S. Then I have to write this as one fraction, one value. So it's like me have a quarter minus 2/3. That's what I'm doing. Put a common denominator of 12. Of 12 multiply this by 3/3 becomes 3/12 minus 3/12 multiplied by 4/4. So look what I did. Multiply this fraction by 3/3 because I want the denominator to become 12. Multiply this fraction by 4/4. Again, I want this denominator to be 12. Right? I could have put them in a calculator, but I'm showing you how you can work it out. This becomes 8/12. 8/12. So it works out to -5/12. So this and this become -5/12 R. Let's write it. Minus 5/12 R. That is the answer. That's it. So this is CD. Right? 2/3 S minus 5/12 R. That's how we go from C to D. 2/3 S minus 5/12 R. Let's continue. OE, the what next? OE. Let's look at the diagram. O can go from O to E. Talk to me now. Remember, E is the midpoint of this line. So talk to me now. O can go from O to E. Look at the diagram. I have to use the diagram.
We'll go from O to C and then C to E.
Good. And then what is the C to E? What is CE? What is
That
CE?
was like, hold on.
Remember, E is the midpoint of CD. You know, I told you. All the vectors questions are always set up. This way, you just find yourself, you're looking to use it down here. Just practice the vectors that way. What you've just found, you're looking to use it down here. So tell me, you're looking to use the CD where it does calculate yourself. That's what the question set up. And then when you find this, there's another part, you're looking to use it on the next part. There's no other part anyway. But tell me, we're going to find the CE, knowing that this is the midpoint. This is the midpoint. This is the midpoint of CD. So talk to me now. Come on. Anybody else can talk, and not one student in the class. You know? It's not one student in the class.
So CSS CE, right?
Look at the
So
question
that
asks
would-
for. The question is asking for OE.
Oh,
So start what you said first based on the diagram. Go from O to E. We're gonna go O to C first and then C to E. Let's write that first. We're gonna go O to C and then C to E. Now this one easy, because we have it. This is just 3/4 R. Question, how we're gonna find the CE? Talk to me. We're gonna find the CE. The CE that we want here. Look at the diagram. What is CE?
Half
Half the
CD.
CD.
Half of the CD. Half of the CD. We'll just find this a while ago. Exactly. So we're gonna write about the OC, because we know that. But the CE is half. It's half of the CD. So we can do it now. So we just need to write half of that. So we're gonna write this OC, which is 3/4 R. See there? 3/4 R. So this is 3/4 R. And then we're gonna write half of this. Half of it. So half of this becomes 1/3. Multiply that by a half, you get 1/3 S. You're gonna get 1/3 S. And then half of this becomes -5/24. -5/24 R. And again, we're gonna put by the only S value that is there, which is 1/3 S. And you need to add this and this, or with a negative. Right? So I now need to work out. I now need to work with a different color. You can put in the calculator and do 3/4 -5/24 if you want. But I can work it out as 3/4 -5/24. I want this to become 24. I multiply it by 6. I multiply this one by 6/6. Because 6 goes 24. Now this right here is 18. So it becomes 18/24 -5/24, which is 13/24. This is 13/24. So I'm getting 13/24 R. So I'm getting plus 13/24 R. That's it, it's done. But go to that. Another nice question. They don't ask us to do anything else. It don't. Oh, another vectors question here. So good. Everybody okay with this one before we move on?
Yes.
All right, let's look to the next one now. Right here. So this one says now, OQ and R have these coordinates. Remember, if you know the coordinates, you automatically know the position vectors. O is just 0, 0, right? O is just 0, 0. You don't find a position vector for O. But Q is this point. So you know that OQ have the same values as this, which is 5, 2. And OR, because of this point is R, then OR has the same values as this, -1, 4. -1, 4. All right, those are two vectors for these 2 points. Let's see what they want us to do. All right. Okay, I can see it's another diagram. To go from O to Q, you have to go 5 units to the right, and then 2 units up. See, this is 2 units. But every other line is a unit, and that's 1 unit. See, this is 1 unit, 2 units, 3 units, 4 units, 5 units. They go 2 units up. 1, 2. So note that every 2 grid, skip a line for 1, right? So like 2 centimeters to 1, all right? 2 spaces to 1. Anyway, let's continue. So down here says, write OR as a column vector. I see, easy question. They give you the point R, they want it as a column vector. Is this the option to find this? -1, 4. So OR is -1, 4. Done. Next one. You want the modulus of QR, which is the length of the line QR now. So let's look, let me show you something now. We're talking about this line, you know, guys. You can literally look at it and go like so. QR, Q to R. QR is this number of units back, this number of units up. So you can look at it and know, you know, how many units this. This comes down back to 0 to here, that's -5, and then -1, that's -6. This is -6. And then this is 1, 2, -6, 2. So I can tell you from now that QR based on the diagram is -6, 2, you know. Because to go from Q to R, I go 6 units back and then 2 units up. So I can tell if I know that that is QR. And therefore the modulus of QR will become the square root of 6 squared plus 2 squared. I do have to put the minus on that. Because in this triangle right here, it's a right angle triangle. The right angle triangle. This side is 6, this side is 2. I'm using Pythagoras theorem to find this length. The modulus is the length. That will be the answer, you know, whatever that works out to. That is 36 and 4, that's 40. That becomes equal to the square root of 40 units. And I can leave it as the answer. That's from the diagram. But let me calculate QR for you now using position vectors. Right? It's going to be the same. Going to work out to be the same minus 6, 2. Let's work it out and show you now. So let's say I wanted to calculate it. I'm just doing this as another method for you. Or without using a diagram. I use a diagram because once I give me a graph, you know, it's easier to just do things on the graph. Well, let's say I'm calculating QR equals OR minus OQ. O times the last minus O times the first. The OR we said was this minus 1.4, sorry. That's minus 1.4 minus the OQ. What is the OQ again? OQ was 5.2. 5.2. So subtracting 5.2. You see, minus 1 and minus 5 is negative 6. 6 minus 2. No, not 6. 4 minus 2. 4 minus 2 is 2. See, it's the same minus 6, 2 that I got on the diagram. So it's because they gave me a diagram, I didn't have to work it out. I could just count how many units horizontally and how many units vertically to go from Q to R. Because that's what vectors is really. Or you displace from Q to R. So it's almost like translation. So I could see from the diagram that QR is that. But you could also calculate it as this. And then now, when you're ready to calculate now, you get that just the same formula. Give you that. All right, square root of this squared plus that squared. Give you the same answer. If you put the negative here, negative 6 squared, same thing. Don't make a difference. All right, and that finishes the question. Any question on that?
No, sir.
All right. So that ends this one, which is 2021. So you all know there was no exam in June 2020. So I want to jump to 2019. 2019. All right. Let's look at this now. 2019 vectors. Always is in section 2. Last question. All right, there you go. Let's see if this part is vectors as well. Nope, that's matrices. All right, let's look at this one. 2019. So this one, I like the diagram once, so I can see a way around, right? It says relative to an origin O, the portion vector of A and B are 9, 0. And they really should put the arrow on top of this. That's a mistake or something that was left out. I made it, they couldn't type it in or something. And you should put the arrow on this as well. All right. So the portion vector of A is 9, 0. That's right here. And the portion vector of B is 3, 6. That's right here. So it's like this is a graph paper, you know, guys. It's like this is on a graph. The y-axis is here, and the x-axis is here. So these are the coordinates. This is the point 9, 0. This is the point 3, 6. Then right here now must be some, like maybe this point is maybe 3, 0. Right here. But we'll work it out. But it's almost like that is it, right? But they didn't show the axis, but no problem. They didn't show the axis, but no problem. Right? So it says the point D and E, that's this one and this one, are on AB and OA respectively, and are such that, and it's giving us such information now. It says AD is 1/3 of AB. So AD is 1/3 of AB. 1/3. 1/3, you know, that's 1 out of 3. So it means that this little piece here so is 1 part. And up here must be 2 parts. Because the total parts is 3, it's out of 3. So the total line AB has 3 parts. 1 and 2, 2 and 1. And this is just 1/3. So if this is 1/3, then this piece is 2/3. This is 2/3 of the entire AB. And remember now, guys, just like the question before, let me put out the 1 and 3 and the 2 here. Just like the previous question, since you know these points, you can find the vector AB, you know, but they ask you for it or not, you can find it. If they ask you for it or not, they can find it. And you're going to need it if you're going to traverse along this side to do anything, to go from any point along that side. You're going to need the vector AB. All right? When you practice, you just know those things. That's how the questions go. When you know those things through practice. All right? When you practice, you know the things that you'll need. All right, so this question asks for it. You see, the previous one did not, but this question does ask us for the AB first. And because we know the portion vector of the A and the portion vector of the B, we can just calculate it using O times the last minus O times the first. All right, so we're going to do that. So AB equals OB minus OA. The OB is 3,6. This is the point 3,6. See here? 3,6. And the OA is 90. So it's 3,690. 3,6 minus 90. So it's 3 minus 9, that's -6. And 6 minus 3 is 3. That's the vector AB. We could see it on the diagram too, you know. To go from A to B, you're going to have to go 6 units back and then 3 units up. Look, you have to come 6 units back. And then you're going to go, that's right. To go from A to B, 6 units back, 3 up. So I'm going to write to this. I don't like this. That's 3, 6. 6 minus 3 is 3. Go from A to B. Minus 6, 3. But this look like 6 up here to me. Say 6 is a Y value. Let me double check this. This one like it making a sense. Oh, I make a mistake. This is 90, not 93. See why sometimes I have to check a diagram. I put 3, should be 0. Not 93, 90. Okay. So that's another skill you must have. Find your own mistakes. So I like this question. You can check your answer and know when it's right. So it's actually 6 minus 0. So it's just 6. Good, makes sense now. See? I was checking to see if my answer makes sense, and it showed me that I made a mistake. But I've got 6 back and then 6 up. That's what this is saying, which makes sense. All right? So that's how I found my mistake. And same thing I told in class. You can check your answer on the diagram, because what you get by calculation must match what the diagram is showing. All right, let's continue. So next I want us to find the vector OD. Let's look at the diagram. O to D. All right, talk to me now, guys. I want to find the vector OD, which is straight across here. We're going to find that. We're going to get from O to D. Look at the diagram. Talk to me. Somebody tell me we're going to go from O to D. But you know this vector, you know this vector up here. Because you know AB. And this is 1/3 of it. Talk to me. We're going to go from O to D. Somebody tell me.
Sir, you go O A and then
We're going to go O to
A to D, or A 1/3 AB, or whatever it's supposed to say.
So AD first, where the AD really is 1/3 of the AB. That's what you're saying, right?
Yes, sir.
Good. All right, that's it. That's correct. All right, so let's go. Let me just do it right here on the diagram so everybody can see it. So to go from O to D, that's what the question wants. We're going to go from O to A first. O to A. And then we're going to go from A to D. The O to A is fine because we know that that is 90. But what is the AD? The AD really is 1/3 of the AB. So it becomes OA plus 1/3 of AB, which we just calculated the AB down here. The AB is this, minus 66. So this is going to become OA, which is 90, plus 1/3 of minus 66, which becomes 90. Do the multiplication here first. 1/3 of the -6 is -2. 1/3 of the 6 is 2. So this works out to 9 minus 2, which is 7, and 0 plus 1 is 2. 7, 2. I can't check if it makes sense. 7, 2. So it's like I saying go from O to D. You're gonna go 7 this way, 7. That's what this means, 7. And then I got 2 up. You got 7, 2. So the answer makes sense. Looks that way. Right? So I can accept it. I can accept this answer. I'm gonna copy this down and put it down there. Right here. That's my OD. Next question I want is BE. BE. Let's look at the diagram. We go from B to E now. Let me take this off. BE. Now we want to go from here to here. Looks like 0 minus 6 to me. And like I just come straight down. Right? I remember they said that OE is 1/3 of this, And the whole thing is 9. Then write this at 3. The whole thing at 9 and it's a 1/3. 1/3 of 9 is 3. So write this at 3. 3 units across. I remember this was minus 6 to come back. And then we go straight up. So it looks like this point is 30. Right? So it means that the vector OE is 30. All right, let's see if that makes sense. Let's work it out. OE is 30, but I want BE. It's BE that I want. So this look like to me this minus that, this and that, right? But let's work it out. Let's work it out. BE O1, right? All right, let's go. BE. So tell me now, how do you calculate BE? How you go from B to E? What do they do? Talk to me.
BO and then OE.
Right, so BE is BO and then OE. All right, we know the BO already, right? The BO really is the minus OB. You know, so this one, based on, look here, so based on this information that they gave me right here, so technically I know OE, based on that information. So I can use O times the last minus O times the first, actually, let's look at it. Based on this information, I will know OE, quotient vector of E. Because OE is 1/3 of 1/3. OE is 1/3 of OA. And based on this information, it means that the vector OE is 1/3 of the vector OA. And OA is 90. 1/3 of 90 is 30. So because I know OE, and I also know OB, because I know OB right here, I can use OE minus OB this time. O times the last minus O times the first, which becomes 30 minus, and then the OB is 36, which then becomes 0, -6, as I said. Comes straight down here, so -6. Go from B to E, comes straight down by 6 units. Based on what was happening in the first part of the question, that's it. So this is the answer right here. That's the easier way to do it. Remember now, once you can use O times the last minus O times the first, you do it. The only thing you rely on the diagram is when you don't have the position vectors. But this one, we had the position vectors. They gave it to us indirectly there. So this is the answer right here, 0, -6. I don't see any collinear points question, parallel vectors question yet. So we're going to have to search for some of those for tomorrow's class. All right, that's it. Let's look at 2018. 2018. Remember, guys, you have to work these questions over again. Watch the video and redo the questions. All right, redo all these examples. Do them all by yourself. Watch the video if you need help. All right, so if you're doing one and you don't remember something, you look back at the video. All right. All right, so one here. Vectors. 2018. I have to search some collinear points and parallel vectors questions for tomorrow. All right, this question said the diagram below not drawn to scale shows a quadrilateral ABCD in which AB is M right here. It's a quadrilateral, it has 4 sides. It says DC is 3M. So since these two are in terms of M, it means them parallel. This one is parallel. All right, just that this now is 3M and this is M. All right, so them parallel. And then it gives us AD right here is N. Basically, it's coming down this way. AD going down that way is N. Right? So it's a finding where around the diagram kind of question. It says complete the statement below on the geometric properties of the following vectors. AB and CD, AB and DC, not CD, DC are what? They are what? Parallel. They are parallel. One is a multiple of the next. They are parallel. And this means this length of AD is something times the length of CD. Remember, modulus means length. Tell me, what is that times here, so? AD, a third. This is 1/3 of this. Very good. Shorter than it is a third. 1/3. 1/3 times. Beautiful. A lot of people put 3 in the exam, but it's actually a third. This question is, what is this one of this one? 1/3. AB is 1/3. 1/3 times the long one. That's it. 1/3. 1/3. Plenty of people put 3 right here in the exam, which is wrong. All right, beautiful. Next one. Express BC in terms of M and N. BC. Let's look at the diagram now. BC. Talk to me. We're going to find B to C. We're going to find B to C. Look at the diagram. We're going to go from B to C. Tell me now. Come on, guys, man. We're going to go from B to C. You have to go along the vector direction that you know. You have to go along the vectors that you know.
Sir, so from to B
to A first, yes.
A to
And
D,
then
then
A to D,
then from
and
D to
then
C.
D to C, as easy as that. And the BA is what? What is the B
M,
to A? Eh?
M,
What is it?
M.
Can't be M, man. M is this way. You're going in the opposite direction to the M. You're going so. See that?
Yes,
It
sir.
has to be minus M.
Yes, sir. Minus.
Minus M. And then AD is what? AD is what? N. Yes, you're going in the same direction as N. So it's plus N. And then here now, D to C is what?
3M.
Plus 3M. And then you consolidate these two. So really and truly becomes n plus 2m. That's what it becomes. N plus 2m. And you can see it to yourself, because I start here. Look at it, the diagram. I start here. If I come parallel to this, that's this. That's an n, you know. That's an n right there. You know? If this is m, then right here says m2. So over here, so must be 2m.
So and the ratio would be 1 to 2. I mean 2 to
But don't worry about the ratio. I'm just talking about how you could go from B to M. What this answer is saying. You're checking if this answer makes sense. N plus 2m. Yes, it makes sense. But this will be n. Come down n this way. And then go 2m this way. That will take me from B to C. So the answer makes sense. See? This answer makes sense. Right? See that?
Yes, sir.
Remember, you know, if the whole thing here so is 3m, and right here so is m. If I complete a parallelogram inside here by drawing a line down here, parallel to this, that means that this length and this length is the same. So it means that from here to here is m. And if the whole thing is 3m, then it means that from here to here is 2m. So it becomes n plus 2m to go from B to C. So the answer is correct. It makes sense. I'm just checking on the diagram. All right. What else they want us to do? They want us to, all right. It says L is the midpoint of CD. L is the midpoint of CD. All right, where's CD now? CD is this. And L is the midpoint of CD. But the whole thing is 3m, right? So the whole thing is 3m. It means, let me write about this now. The whole thing is 3m. Let me erase this. I erase this thing. The whole thing is 3m. It means that right here is 3 over 2m. And from L to C is another 3 over 2m. It's like you have a 3m and you divide it in a 2. So you have 3 over 2 and 3 over 2, right? Good at that?
Yes. Yes.
Yeah, man. Yeah, man. Half of it. Because this is the midpoint. So it divides the 3m, half and half. So it's 3m over 2 and 3m over 2. That's what it is. 3m over 2 and 3m over 2. Half and half. Right? So it's 3m over 2, which is the same as 3 over 2m. It's the same thing. All right? So they want us to find the vector now. What do they want us to find? BL. BL. So talk to me now. I want to find BL. Look at the diagram. I'll go from B to L.
So we can go from B, would that be minus m? I mean,
Same thing again, man. Just come around here, so. Come around here, so. Come down here, so. Come there, so. See that?
yes.
So it will be minus m plus n plus 3 over 2m. That's it now. But let me show you another way now. Based on what we just did a while ago with the breakdown. Remember I showed you that you could have come down here at n. That's an n. So remember now that this length and this length is the same enough to here, so. So right here, so is m. This is 1.5 m now. 3 over 2 is 1.5 now. So if this is 1m, it means a little piece of left right here, so is half m. So B to L, I can tell you from now is n plus half m. That's what BL is. N plus half m. It's on this diagram. But let's say I never realize that. And we have to work out everything. Right? Let's say I never realize that. And we have to work out everything. Then we will go the same route again. Let's put on in red. Let's see if it's in red. We'll come back here, B to A first. So BL will be B to A, and then A to D, and then D to L. The B to A is minus M. We're going in the opposite direction to the M. The A to D is N down here, so N. So adding an N. And then the D to L is 3 over 2M. 1.5 M. So this is the only N there. 1.5 minus 1 is a half. So it's a half M. Same thing as I told you. So these would be my answers. That's it. That's my BL. Let's copy it down. Right here. Very easy questions. Very easy. Change the color to blue. That's it. That's it. That's it. How long now we're going? Started at what time? We're not going 2 hours yet, man. Just 6:45 now. Yeah, man. Let's continue working. 2017. 2017. 2017. Maybe I need to bring up back one of my questions before I finish. The collinear point. I'm not seeing any collinear points parallel vectors questions. I like those questions. Let's see this one. I tell them question I'm too straightforward. Okay, let me bring up back one of my questions, man. Yeah, question are too straightforward, a little bit too straightforward. State 2 relationships. Okay, so if you're doing a question, and question asks us to state 2 relationship between 2 lines. These are 2 lines. It's gonna be that they are parallel. You have to work it out and you have to show that they're parallel. And the next relationship is about the length, the ratio of the length. How long one is relative to the next one. That's the 2 relationships. We're gonna say that the parallel, they're gonna say what the relationship between length is like. One is 2 times as long as the next, something like that. If they ask for the relationship between 3 points like A, B, and C, there's gonna be that they are collinear. Points are collinear. That's how these questions go. They ask about the relationship between 3 points, look to see if they are collinear. Remember, with the collinear, one vector, for example, equals 2 times the other vector, like maybe BC. Parallel vectors with a common point. In this case, the B will be the common point. All right, so you want to establish something like this. If the relationship between 3 points, there's asked. But let me go back to my sheet because we can come back to do some more of these questions tomorrow. Let me go back to the worksheet and do a question from it. The homework thingy. Now notice I've not done the question that I sent in the group yesterday. Yesterday I sent it, or the day before, or the night before. I want you know to do that question. I said, those of you who did not feel inclined to try it, I wanted to try it now. All right, I want you to try that question, the one that I sent in the group. All right, I'm gonna do a question from our class document. Right. So we did this one already. Let's do this one now. All right, let's do that one. At least this one asking us about some collinear points. All right, and then maybe can do this one as well, or maybe maybe tomorrow we'll do that one. All right, let's go. Let's do this one. Let's split the screen. All right. So we want to do this question right here on the screen. All right. This question right here. Question says the position vectors of A and B relative to an origin O are small a and small b there. Notice how to put them in italics, let them bold them. I'm going to underline them when I'm working. All right. So this is a vector A, that is a vector B. Question says the point P is on OA. So there's a point on this line such that OP, O to P, is 2 times PA. Notice, you know, O to P is a long piece, you know. PA is a small piece because it's 2. So OP has 2 PAs in it. So the line is broken down into 3 parts. They like the 1/3 relationship. So it's like P somewhere all the way up here. It's like the line is broken down into 3 parts like this. Right? And the P is right here. So see this PA, the OP has 2 of it in it. 2 of this fits inside here. OP is 2 PA. Right? So basically, this is a good indicator of where P would be right here. This has 2 parts. Let me erase this. 2 parts down here. 1 part here. So the whole vector is A. That means that this is 2/3 A and this is 1/3 A. Look at this, you know, guys. OP is a long part because it is equal to 2 times PA. There are 2 PAs fitting into OP. So OP must be the long piece. And there are 2 PAs in it, in the OP. All right, practice, get familiar with these things. So what I'm going to do, I'm going to erase this A again and show it as the 2/3 and the 1/3. I'm going to erase this. Erase this. All right, and mark about this line. I'm going to mark here as 2/3 A. So let me take this off. It's 2 parts. I'm just marking here as 2/3 A, both are 3. And from here to here is 1/3 A. The more information I can put on my diagram, the better. 1/3 A. Understand that?
Yes, sir.
All right. That point is P. Then it says now, the point M is on BA. Point M is on BA. So BA here. Such that BM is equal to MA. It means that M is the midpoint. If BM is equal to MA, then M is the midpoint. So right here, I'm going to put M right here. Right in the middle. M is the midpoint of BA. It says copy the diagram and show, copy and complete the diagram to show the points P and M. That's it. So the point P here, so the point M there. All right. Now remember now, guys, let's look again. We know the portion vector of A and we know the portion vector of B. So technically we know this now, guys. We know BA or we know AB. They ask us for it, whether they ask us for it or not. can find that vector. Because we know the two position vectors. We know the position vector of the A and the position vector of the V. So we can find the AB, or we can find the other way, the BA, this way. So we technically know this vector. All right. Next part now says, it says OB is produced. Remember that word I told you about? Produced is another word for extended. OB is produced to N, produced to N, such that OB is equal to BN. So B becomes the midpoint between O and N. All right? So OB, this line OB is produced, means extended. I'm going to leave it on this same diagram up here. I'm not going to redraw a diagram. I'm going to leave it right on this diagram. So I'm going to take this side. I'm going to extend it. Let's do the extension in purple. This side. I'm going to extend it. So like I'm putting on another B on it, because this becomes the midpoint of ON. So this is extended up like this. Leave it around here. Such that now right here is the point N. And that point is N. This vector is B. And this B becomes the midpoint of ON. That means that the vector here is also B. So we can write that from now. And put on in red. I'll put on in blue. This vector here is also B. Are you good at that?
Yes.
Are you okay with that? All right, good. All right, so using this diagram as we have it here. Then it says show N on the diagram. That's it. N is right here. Extended. So this slide is extended, so that this is now the midpoint. So this is B, this is B. Vector B, vector B. All right. Next part now says express in terms of the A and the B, these vectors, A, B, P, A, and PM. Those three things I want. So first thing I want is B, AB. Easy, that one easy. Because AB is simply OB minus OA. The OB is small b and the OA is small a. That's the vector AB. Done. Then I want the vector PA. We worked out already, right here. PA is 1/3 A. So PA became 1/3 A. We worked it out already. It's on the diagram. And then now the one PM. P to M. So somebody tell me now, we're gonna get PM. So this is, let's call this part, let's asterisk them. First thing, second thing, third thing now is PM. Look at the diagram now, we're gonna find PM.
Third, 1/3. I mean, yeah, 1/3 of.
No, tell me the points I'm gonna go to first. From P to M, where we're gonna go first?
P to A and then A to M.
P to A, and then A to M. All right, so what are we gonna do next?
So
We know this already, we know this, right?
yes,
What is the AM equal to?
1/3. Wait, oh, AM,
Yeah,
half of BA, I mean AB.
right, and this is the AB, right? So we have PA, and the AM right here is clearly half of this, half of the AB. Where the AB is what we just work out up here. This is AB. And the PA is what we just work out here. So as your question set up, these first two things, we use them to find this third thing. All right? So that's what the questions always are set out. So it's therefore works out to 1/3 A. That's what the PA is. Plus, we're doing half of these, half of those. So you have a half this part and half this part. So it becomes half of B minus half of A. That's what this is. Becomes that. And I want to have consolidated values. So this is only B terms. I'm going to write it. Half of B. Then this becomes 1/3 minus 1/2. Let's set it up. 1/3 minus 1/2. All right. So I want the 2 denominators to become 6. Multiply this one by 2 over 2. Multiply this one by 3 over 3. So this numerator becomes 2, so it becomes 2 over 6, minus becomes 3 over 6. So it works out to be negative 1 over 6. So this and this become negative 1 over 6. So we get minus 1 over 6a. Minus 1 over 6a. Now we can check if it makes sense. This is saying to go from P to M, we go half in the direction of B, and then minus 1 over 6a. That's what it's saying. Let's see if it makes sense. So put down in red. So we go half in the direction of B. So like you go half of the length here. Which is so. You want to put the P exactly right place. But then we'll go 1 minus 16a, one the piece of A. Come back. What was A? No, I lie. Wrong. So when half of this up here, half of this. Go half of this, transpose the way. So half B. That's half B. Up to this. And we're going minus 1 over 6, minus 1 over 6a. Remember, A is this, you know. Remember, all of this is the A, you know. Oh, only a little piece, 1, 6. But then we're going in the opposite direction. So you see, it kind of makes sense. This looks like minus 1 over 6a for true. Looks like minus 1 over 6a for true. And this looks like a half B. So I can live with those numbers. It looks like it makes sense. All right, we go from P to A to M. But this is the answer I'm working with, PM. So PM is this. All right, so I've completed this part. Next part now says, use a vectors method. Use a vectors method to prove that these 3 points are collinear, PM and N. PM and N. Let me put on the diagram now. These 3, PM and N. PM and N are collinear. So if I draw a straight line, it's supposed to pass through the 3 of them. Yeah, almost good enough. Like that. They are on a straight line. But I want to use a vectors method. Remember, to show that 3 points are collinear, you have to show that you have parallel vectors with a common point. So you have to choose 2 vectors that they're going to use to work it out. 2 vectors that they're going to use between the 3 points. All right. So we have one already. We have PM. PM. So you need another vector between the P and the M, between another vector, either PN or MN. You have PM already. You already have this one. So you're either going to use PN or you're going to use MN. Because you're already going to be using the PN. You don't need, you can use any 2 vectors. So tell me now, to show that the 3 points are collinear, let's write it out. PM and N. Let's set it out like this. We're showing that P, M, and N are collinear. So we say we're going to use the PM. We know we're going to use the PM. So PM is a half B minus 1/6A. And which other vector we're going to use? Which other vector we're going to use? Somebody tell me which vector look like it. We want to use the easiest one possible that we can use. Anybody can tell me which one is easiest one to use? Somebody tell me. Is that we're going to use PN or we're going to use MN? One of the 2. We must use a vector with the N in it. We are already using PM. So the other vector to use along with the PN is either PN or MN. Which one is easier to find? Which one is easier to work out? We have PM already. Which other one is easier? Which other vector is easier to work out? We can use any 2 vectors. So apart from PM, because we have it already, the PN or the MN, which one easier to work out?
NM.
Huh?
NM.
No, remember, I know, since we're going this way with the PM, you want a vector going the same direction as the first thing. So you're either going to use PM or you're going to use MN. Look at the diagram and tell me which one easier to find. I'll write them out for you. Pn or Mn, which of these two vectors based on the diagram is easier to work out? Look at the diagram, good. Which of them is easier to work out? Pn or Mn, which one easier to find based on the diagram? Looking at the diagram, which one easier to know the answer for? Pn or Mn, which of these two vectors? Which one is easier to work out? The
So
Pn.
may I go with Mn, you know?
You say Mn easier to work out?
Yeah, that's something I think about.
I look on the Pn. Pn you have to calculate none. If you go Mn, you have to calculate and work out a piece here and then a piece there. If you're going from M to N, you will come across here, so this way, and then go up here, so you have to calculate a piece here and do some calculation. Look at the Pn now. If I'm going from P to N, based on the diagram, I just come down here so I know that. I'm just go up there so I know that too. Up to 2B. So I already know the two things I'm going to use to calculate nothing. The Pn actually easier. You see me I say?
Yes, sir. I never see that.
But up on the diagram right in front of you, you don't see it. Right? It's on the diagram. You don't looking to go, or you can go from this point to this point, going along the vector direction that you know. So you can clearly see you can come down here so first with this, basically a minus, and then go up there so with the 2B. And you don't have to calculate nothing because it's there on the diagram, it's clear. But if I'm going to go from here to here, whatever, come across here so, and I don't know that, I have to work it out. And then add the B. I'd have to work, I would use the half of the AB. It is easy. I have to still do some calculation, but go that way. Now, I don't know, but I have to still do some calculation. While if I come down here and then go there, I don't have to calculate nothing. Because I know that coming down here is just minus that. And going up here is 2B, B plus B, 2B. So Pn easier, boss. Pn easier. So I'm going to use Pn. All right? And that's what the questions are at the time. You have to look and see which one is easier to use. So I'm going to use Pn. Because Pn clearly is minus 2 over 3a plus 2b. See that? So these are the two vectors I'm using. Just that, if you notice, this one has the a second and the b first. So I'm going to spin around these two to set it out in the same order as that. So I'm going to write it instead as Pn equals 2b minus 2/3 a. So we have the b first, a second in that one, b first, a second. Then now, I want to show that these two vectors are parallel, and P is going to be my common point. To show that 3 points are collinear, you have to show that you have parallel vectors between them with a common point. One of the points will be common. But you have to show that these two vectors parallel first. So we're going to show that these two vectors parallel. What are the steps to show that they are parallel? What are the steps? Because to show that they are parallel, you need to show that one is a multiple of the next. You need to show, for example, that Pm equals some constant times Pn. Something like that you're trying to get to. What are the steps to get to something like this? What are the steps? I gave it 3 steps in class. You have to remember them and use them. Come on, what are the steps? What's the first thing you do?
Try to see if there's any fractions.
Eliminate the fractions. Why do we eliminate the fractions?
Because it would be better.
It'll be easier, sir.
This be
Good.
easy to calculate.
Not easier to calculate. It's easier to see the relationship between numbers when they are whole. Like for example, you know the relationship between 4 and 16, rather than the relationship between 2/3 and 1/7. When the numbers are in a fraction, it's more difficult to see the relationship between them. This is clearly a 4 times relationship. When the numbers are in whole number form, it's easier. Same thing with the vectors. When the vectors are in fraction form, it's more difficult to see the relationship between them. Remember now, one is a multiple of the next, that's what they were trying to get, want to see what the multiple is. So they get rid of the fractions. The fraction make it more difficult to see what the multiple is. So what do we multiply this one by to get rid of all fractions? Doing this one first. Multiply by what? I don't want the fractions. This is the only fraction. I don't want it. What do I multiply it by? Multiply by the denominator.
3.
Come on, man. Multiply by 3. Remember to multiply everything by the 3. So multiply this by the 3 as well. So you're going to get 3pn equals, this becomes 6b. And it becomes minus 2a. Good? And this one, I don't want the fractions in this, but I multiply that one by. To get rid of the fraction.
3, sir.
Huh? What do I multiply this one by to get rid of the fractions? I don't want the fraction. What do I multiply by? To get rid of all fractions. It's easy, you know, guys. It's the lowest common multiple of the denominator. The lowest common multiple of the denominator will get rid of all the fractions. The lowest common multiple of 2 and 6 is 6. Common multiple of 2 and 6 is 6. 6. 6 is a multiple of 6. You know, 6 times 1 is 6. 6 is also a multiple of 2. 2 times 3 is 6. So the lowest common multiple of 6 and 6. 2 and 6 is 6. I'm going to multiply by 6. That will get rid of all the fractions in this one. So I multiply this by the 6. Remember, I multiply this by the 6 first. You get 6pm equal, I multiply this by the 6. I get 3b. Multiply this by the 6. I get minus a. So I have these two now. I'm comparing these two now. I want them to become equal. So what do I do next to get them to become equal? I multiply up the small one to make it easier to equal to the large one. Which one is the small one? This one or this one? Which one's smaller?
Sir, the 6 p.m. The whatever.
This one's
top one.
smaller.
So you
This
multiply
one's
by
smaller.
6.
So what do I multiply that one by to make it equal to this one?
2.
2. Multiply this one by 2. Because I'm trying to get these two sides to be equal. So I can equate this to this. That's what I'm trying to do. So I multiply that by 2. I multiply this by 2. This becomes 6pm, sorry. And this now becomes 6b minus 2a. Same as this now. Now that those two are the same, I can equate these. I equate those. Right? I equate those to work out itself in the end. So I'm going to equate next. Equate. Because the two of them equal the same thing. Right? So when I equate now, I put 6pm equals 6 this one. It's at 12. I'm multiply that by 2 becomes 12. Say my mistake. 12. I multiply everything by the 2. So it becomes 12. So get 12 pm equals 3 pn. Now we can divide both sides by 3. Divide both sides by 3 now. Right? So in essence, but this is about 2 on it and a 2 on it, you know. That's what happened. Right? But no matter, I work out itself. What I could have done earlier to make them become equal. No, don't worry about that. Don't worry about that. I just divide through by thing now. I could have just multiplied this one by a 4 and it would have been equal to that. Because this would have become 2b like that. So I could have multiplied this alone by a 4. But it don't matter if I follow the process, it work out itself because you equate and then simplify. So divide both sides by 3 now, by 4 now, 3 now, sorry. This becomes 4pm equals pn. That's it. And once you reach here now, you have a common point on the parallel vectors. So there are 2 conditions for collinearity. One is that they are parallel because this is a multiple of this one now. It's 4 times. It means that they are parallel. PM parallel to PN. This is a symbol for parallel. And the second condition is a common point. P is a common point. And once you have these two things happening, parallel vectors with a common point, means that the points involved are collinear. So P, M, and N are in fact collinear. They are collinear. And that's it. So I've shown that the points are collinear. Only says, so calculate the length of AN if A is this and B is that. AN, the vector AN, the length of it. So remember the length now of AN. One is a square root business. A squared plus B squared. No, let's not use A and B, but square root business, right? Like x squared plus y squared when the vector is xy. So we need to calculate the vector. We need to find the vector AN. Let's look at that diagram. Everybody okay with this over here first before we move on? Everybody okay with that? Huh?
Yes, sir.
Yes, sir.
All right, so on the vector AN now. AN. That's from here to here. We need that vector AN. But it's easy, you know, because we know the position vector of A, we know the position vector of N. I look at it this way, you can come minus A plus 2B. That's AN, you know. Minus A plus 2B based on the diagram. Minus A plus 2B. So it's easy. That's AN. Minus A plus 2B. Let's work it out down here. So AN is A to O, and then I can use O times the last minus O times the first, you know, because the position vector of N is 2B, and the position vector of A is OA. So we can use ON minus OA. O times the last minus O times the first. All right, so the ON is 2B, and the OA is A. And it's telling us down here, so now, see here, that the A is this and the B is that. So it becomes 2 times 1, 2. Not a fraction, 1, 2. Because the B is 1, 2. Minus the A. The A is 6, 2. 6, 2. So it becomes 2, 4 minus 6, 2. So it becomes 2 minus 6 is negative 4. And 4 minus 2 is 2. That's the vector AN. Was the length of AN the one, you know, which is the modulus. The length of A is the modulus. So the modulus of AN becomes the square root of 4 squared and 2 squared. 4 squared plus 2 squared. I don't have to put the minus on this because the same result. Now this is 16 and 4, 20. So it becomes the square root of 20 units. That's what it becomes. That's it. That's it. What do we do with that? I think I'm going to stop it right there for today.
Yes, sir. Yes, sir.
All right. All right. So I'm going to leave it here for today. Tomorrow, we're going to continue. There's some more questions. Might do a couple more questions on this. Maybe like this one over here. And some others. And also some other past paper questions. I think I'm going to do a class activity Sunday and Monday. And then we have a class work Wednesday and Thursday next week on this topic. All right. After this topic, we're going on to trigonometry. I'm going to start some trigonometry work. All right, guys. That's it. You know the program. You know my instructions at all times. Watch over the video. Read the questions. Watch over the video. Read the questions. Those questions that the paper that I worked on today, they are in the group. They're already in the group. So we did the June papers, 2023, 2022, 2021, 2019, I think 2018. They are already in the group. So let's search for them in the group. I don't have to send them again. and just work the vectors question on them. All right, the video is available right away because it's on YouTube. So I'm basically recording on YouTube, so you can just go and watch it there. I didn't want to use the Zoom to use up the space on the Zoom. And the Zoom has limited space. Right? I have a lot of pair maths and add maths stuff, and the students really depend on the videos on Zoom. Most of the students in my add maths and pair maths class are online, so they use the videos a lot. All right, so that's why this one on YouTube. So the video is there. All right, guys. So have a good night. Do as I tell you, please. Tomorrow again, we're gonna have a session tomorrow again for everybody, not just the Sunday students and not just the Monday students. Everybody join the session tomorrow again online. We'll come back face to face on Sunday. We're gonna have another online session on Saturday, as usual, to practice some more vectors questions. More maths equals better maths. More practice, better we get. And remember, every time I do a question, you are to go and redo those questions. All the examples that I do, you are to go and redo them. All right, that's the method that we use in this program. You go and redo the examples that I do. When we get to March, you are going to be doing the questions first, and then I will do them after. But for now, I do them first, then you do them. All right, apart from the ones that we're doing classwork. All right, bye everybody. See you tomorrow. Bye-bye. Good night.
Bye, sir.
All right, cool.